Today we're going to be talking about exponential equations. And in order to solve exponential equations, you're going to need to know how to change bases. So we're going to work on that first. Problem number 1, we want to make the numbers 3 and 81 both have the same base. And if you go back to our example, should start with that, 8 and 32. 8 can be written as 2 to the 3rd power. And 32 can be written as 2 to the 5th power. So they have both the same base of a number 2. So that's what we want to do in today's lesson, is we need to create common bases. So there's a couple ways that you can do this. One, you can just know what they are. For instance, 3 is 3 to the 1 power. And 81 is going to be 3 times 3 times 3 times 3. So that's going to be 3 to the 4th. So one way is you can expand it out. If they're all the same number, it's really easy. There's 4 of them, so it's 3 to the 4th. You can try to guess. Like for 8. 8 is, well, it's not 2 squared, and it's not 2 times 4. You have to understand its powers, bases and powers. So let's see. 8, we can try to do this. Oh, we have it up there. 8 is 2 times 2 times 2. So that's 2 to the 3rd. And then 16 is what? 4 times 4. So that's going to be 2, 2, 2, 2. So that's 2 to the 4th power. And then we have both of them having a same base of 2. Problem 3, 25 and 125. Again, this one's not that hard because 25 really only has one base. It's 5. So that's 5 squared. And once you know that you're dealing with 5s, you can just start checking on your calculator. So you could try, well, what's 5 to the 3rd power? Oh, and there's 125. So that's another way to do it, is just try to figure out what base number you think it might be and start guessing. Okay, so there's 5 to the 25 is 5 squared, and 125 is 5 cubed. All right, let's try 3 more. So 16. 16, again, I can try to expand this out, or I can guess. I know a lot of times students want to do like 16 is 4 squared. You could try that. And then, okay, then you could say, okay, can 64 be a 4? Well, let's see. 4 to the 3rd power would be my next number. And it does, in fact, work. So that's 4 squared, and that's 4 cubed. There actually was another answer, though. You could have also used 2's. You could try 2 to the 3. Nope, that's 8. All right, so try 2 to the 4. 2 to the 4, there's a 16 as well. And then let's see if I can get 64 to be 2 to a number. So let's try 2 to the 6th. Oh, it is 2 to the 6th. It doesn't matter which pair you use, as long as you can get them both to be the same base. So either pair, either the 4 bases or the 2 bases would both have been acceptable answers. Okay, number 5, 36. Again, this is a kind of an easy one because 36, there really is only one way. 36 is 6 squared. So all I got to do is see, can I get 216 to be a 6? So I'm just going to go ahead and guess and check. Well, let's see. 6 squared is 36, so let's try 6 to the 3rd power. Oh, and that's 216. Now, if you want to do this the expanded way, I got to show you this is a little bit different. If you try doing 36 is 6 times 6, and that's 2 and 3. This is how you're going to have to do this. You have 2 2's and you have 2 3's. Try again. What you're going to have to do is you're going to have to line up the different numbers and make them both 6's. 2 times 3 is 6, and say that's 6 squared. So that's also what will work with 216. So you can do it the expansion way. Just note that if you have different numbers, you have to pair them up and make it one group instead of two different numbers. Okay, and finally, number 6. All right, we have this funky 1, 7, and 49. Well, I'm going to deal with the 49. 49 is easy. There's only one thing. It's 7 squared. So can I make this a base number of 7? Well, if you notice, we have the right number, but it's in the denominator. And a couple days ago, you learned about how to flip fractions, what power does that. The 7 remains the same number, but it's on the bottom. So if I want to flip it up, I need a negative in the power. And since it's the same number, I want to keep it a 7, so I have a 1 power. So 7 to the negative 1 power would give me my 1/7, and 7 squared will give me my 49. So I have both bases being 7. All right, if you can do changing of bases, then solving exponential equations is really easy. So the reason why is this. For number 7, we want to know what x number would make 5 to that number equal 5 to the 4th. Now, they both have a 5 base. So if they both have a 5 base, the only way a 5 to the 4th can equal a 5 to the x is if this number x is a 4. Has to be. 5 to the 4th power equals 5 to the 4th power. So that's what our objective is today, is we want to get the bases to both be the same. Now, sometimes they might be easy. For instance, problem number 8, what number can I make a 2 be raised to? So 2 to what power will make an 8? Now, I could guess 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 2 times 2 times 2, which is 8. So there's my answer. They're not always going to be this easy, though. So problem number 9, I want to know what number power for x can I raise a 4 to make it be an 8? Well, 4 to the 1 is 4, it's too small. 4 to the 2nd is 16, that's too big. So it's got to be some number between 1 and 2. Again, I can sit here and guess, but there's a better way. If I can make them both be the same base, then I can do what I did in problem 7. If I know the base numbers are the same, it means the powers have to be the same. So let's see, 4 is, there's only one thing to do. 4 is 2 squared. And then I have an x power. 8 is 2 to the 3rd power. Once I have the bases be the same, I know then that the 2x power and the 3 power have to be the same value. So I make up a new equation. The 2x power needs to equal the 3 power. Now I just have to solve for x by using regular algebra. So the answer is in fact a number between 1 and 2. 4 to the 1.5 power or 4 to the 3/2 power will make an 8. All right, so that's our lesson for today, is solving exponentials, and we're going to do that by creating the same base. Okay, so an exponential equation, if I can get it up, it's an equation that has a variable in the x power. Sorry about that. So an exponential equation is an equation in which at least one of the terms in the equation contains a variable in the exponent. And in order to solve this, there are two algebra methods. We're going to learn one algebra method today, and there's another one that you cannot do until we learn something else. So we're just going to stick with changing the base method today. So I'm going to just focus on the base numbers. All right, so when I see these problems, I'm first going to focus on the 4 and the 2. I need them both to be the same base number. Well, 4 is 2 squared. So that's 4, and 2 is just 2. So what we're going to do now is we're going to keep the remaining items. There was an x power on the 4, and there was a 3x plus 1 power on the other side. So all we're doing is touching the yellow. The yellow is right there, what I put in parentheses. Now we're going to use our power rules. Anytime we have a power to a power, we multiply that. So we're going to have a 2 base and 2x power equaling a 2 base again and a 3x plus 1 power. If the bases are the same, then the equation has to be such that the powers are also the same. So that means we know for a fact, and we're not dividing out the 2's, we're making a statement. If the bases are the same, the powers are the same. So at this point, we have a simple equation. All we have to do is solve for x, our normal algebra rules. And x is -1. So there is another algebra way. You'll learn in a few days from now what that is. But I also want you to keep in mind that you can always do these problems the graphic method or table method. You're going to put the left side of the equation, the original, in graph 1. You're going to put the other side of the equation, the way it originally was, in graph 2. These graphs can get kind of ugly looking. They get really steep really fast. And it may be hard to see where they're hitting because they will be kind of close together. As I always told you, you can also look at the table, but be careful. Sometimes if the answer is a decimal, you won't see it. And all I have to do is find the matching y values, and they do happen here. So I can see that my answer is -1. So again, that's what you would put in your graphs, whatever calculator you have, graph 1 or graph 2. You can either do it on the graph. If you do it on the graph, just be careful. The graphs kind of can get really tight here, but they are hitting right here at -1. Really hard to see that. You can do intersection by doing second trace on the 84 calculator, number 5 for intersection. And then just put your cursor near the spot. It doesn't even have to be perfect. And you're going to do enter on the 3 questions. And there's your answer, -1, 0.25. The answer is just the x value. If you want to do it the table way, that's fine, but your answers are not always going to be whole or integers. If you want to do the table way, you would in fact put this table on your paper, and that could also be your work. Okay, so moving down to example 2. All right, solve the following for x. Again, once I have base numbers that I'm working with, the first thing I'm going to try to do is get the base numbers to be the same. So I'm looking at the 3 and the 9. Well, 9 is 3 squared, and 3 is 3. So we have both the same base. I keep the original powers where they were. All I did was change the base. Power to power, I keep the base and I multiply the powers. Well, this power is going to stay x plus 2. And then over here, these two powers get multiplied together and make 2x. Once I have the same base, I just set the exponents equal to each other, because if they both have 3 bases, the exponents must be the same. So that means that the x plus 2 power has to equal the 2x power. Now all I have to do is a simple solving. You do not need to check them, but it always is a good idea on a test or quiz to check your answers to make sure that you are on the right track. Okay, problem number 2. Look at the bases. They actually are both the same right now. So there's no change that I need to do right now. All I have to realize is if I have the same base, the powers must be equal to each other. So the x squared minus x power has to equal the 6 power. At this point now, I have a x squared equation, so I'm going to think equals 0. Factor it. And solve, and I get 2 actual answers for this one. Both x is 3 and x is negative 2 would make those both be equal to each other. Okay, so we'll try 3 more examples together. Too far, sorry. Okay, so problem number 4. I have base numbers, so my first goal is to get them both to be the same. They are different, so I have to think about what can I make both a 4 and an 8 become. Well, 4 is, there's only one thing for 4. It's 2 squared. And 8 is actually 2 to the 3rd power. Keep everything else the same. So now I'm going to simplify. The base number stays. Power to power, though, I have to multiply those two together. Be careful. You have to distribute the 2. If you want, you may want to write this. So you may want to slow down and actually first write that you want to multiply those 2 together and then multiply it. Or right now we can go, okay, I know that if the bases are the same, I know that the 2 powers have to be the same. Then I can multiply it at this step. So distribute the 2. I get 4x plus 2 equals 6x. And now I have a real simple equation to solve. Okay, problem number 5. I have my base numbers again. 81 and 27 is what I want to focus on right now. So this one maybe is a little harder. You can again guess and check. Some of you guys might know right now what the common base is. Once you start practicing this a lot, you'll find that it actually gets easier to determine what the base is. So here we go. We can try, let's see, 81 is definitely 9. So you could do like 9 squared. But then I need to make 27 be a 9. So I can try 9 to the 3rd. But see, that's too high. So it can't be 9. So let's try 3. 3 to the 3rd. Oh, there's 27. So what about 3 to the 4th? And there's 81. So there are my numbers. So 81 is 3 to the 4th, and 27 is 3 to the 3rd. I'm going to keep the regular powers what they were originally on these problems still. So now I have the base 3. And the new power is 4 times x plus 2. Okay, 3 base. And new power is 3 times 5x plus 4. All right, once I have the same base, I know that the powers have to be the same. So I now know that the 4 times x plus 2 power has to equal the 3 times 5x plus 4 power. Now I'm going to do regular solving rules. Distribute. All right, distribute again. And then just solve for x like you typically would. All right, and again, you will get not so nice answers. You can have a negative answer or a fraction answer, so your answer is -4/11. All right, we'll do one last problem together. So on this problem, if I look at my bases, 5 and, well, the 1 doesn't do anything. I'm really focusing on the number 125. 5 can't break down any further. So that's what's kind of nice about this problem is you don't have a choice. 5 is just going to be 5. So that's going to stay 5. But now I have to somehow get this to be a 5. Well, first I can focus on what number would make 125. So we can guess, or we can just do a prime tree on 125. Let's see, 125 is 5 to the 3rd. There's 125. But it can't just be a 3 power because that's going to be a 125. Don't forget, if you ever want to flip a number, you need to have a negative on it. So that's going to be 5 to the -1/3. And I can just show you it's going to work. There's my decimal, but I can always change it to a fraction on either calculator. On the 84, hit math, and then number 1. And then you can see that that, in fact, is correct. All right, and then there was no power on that one. So at this point now, we have a 5 base and an x minus 1 power. And we have a 5 base and a -3 power. Once the bases are the same, I now know that the 2 powers must also be the same.